Dear students, today I am going to explain about the schedules based on recoverability. First we have to define what is meant by schedule, and then we can classify the schedules based on the recoverability or non-recoverability and so on. First we will define what is meant by transaction schedule or history. When transactions are executing concurrently in an interleaved fashion, the order of execution of operations from the various transaction forms what is known as transaction schedule or history. Okay, the order of operations performed in the interleaved transaction is called as schedule or history. So, the four possible schedules are shown in the transactions T1 and T2. So, we will take here, we are having four schedules, schedule A, schedule B, schedule C, schedule D. In each schedule there are two transactions T1, T2, T1, T2, and how that operation should be performed from top to bottom and left to right. Okay, and each schedule includes same operations, different order of operations in each schedule. So here first schedule will take schedule A. First that completely the T1 should be completed. The T1 schedules will be, the transaction will be completed. Then T2 is completed. That is first read operation write X. Then read Y write Y in T1. Then the T2 operation should be completed. Again here read X and write X. And in schedule B, again the write up this T2 transaction is completed. Then T1. But if you will take transaction schedule C and D, T1 some operation performed, again T2, then again T1, T2, T1 and so on. Same thing for schedule D also, T1, T2, T1. Okay, so this is a thing happened. So that is a different types of schedules we are having. So schedules can be displayed in more compact fashion. How it will be means, read means we can use read only. Read means R. It is belongs to the transaction 1 means R1. The item it reads is X means R1 of X. Same thing for write operation means W1 of X for transaction 1. Transaction 2 means R2 of X, W2 of X and so on. And for the beginning of the transaction we are going to represent with B, end of the transaction we are going to represent with E, commit means C, aborted means E, sorry A. This is the notation used for formal notation used to represent the schedules. For example, the first schedule is represented as R, this is read of X, this belongs to T1, no? So R1 of X, then W1 of X, R1 of Y, W1 of Y, then R2 of X, W2 of X. Okay, that is a transaction schedule A. Schedule B, how we can represent? R2 of X, W2 of X, R1 of X, W1 of X, R1 of Y and W1 of Y. Like that we should represent other schedules also. So this is the notation used for representing schedules. And next is, we can characterize the schedules by classifying them based on ease of recovery. Okay, whether the schedule is recoverable schedule or non-recoverable schedule, we can characterizing into, first we can characterize into recoverability schedule and serializable schedule. Then again schedules classified into the two major classes, that is recoverable schedule and non-recoverable schedule. Recoverable schedule means one where no committed transaction need to be rolled back, that will be aborted. No committed transactions. Once it is committed means permanently it will be stored in a database, otherwise it will be aborted. So for schedule S is recoverable if no transaction T in S commits until all transactions T dash have been returned an item that T reads have been committed. Okay, then it is recoverable. Non-recoverable schedule means a schedule where a committed transaction may have to be rolled back during recovery. So that is called as non-recoverable schedules. For example, schedule A below is, that is schedule A, B, C, D we have seen, no? A is non-recoverable because because we'll take here A is non-recoverable, because here before committing that T1, the T2 reads the value of X. So see here, so the non-recoverable because T2 reads the value of X that was written by T1, but then T2 commits before T1 commits or aborts. Okay, so to make it recoverable, the commit of transaction T2 must be delayed until T1 either commits or aborts. That is important. Then it is recoverable. That is okay. Otherwise, it is non-recoverable. If T1 commits, T2 can commit because T1 is completed first in schedule A, then T2 is completed. So first T1 should commit, then T2 can commit. If T1 aborts, T2 must also abort because it read a value that was written by T1. See here, if you take here, that is T2 reads the value of, that is what value the T1 has written, X. Write X, that only the T2 reads. So T1 is aborted means T2 also aborts. This value must be undone when T1 is aborted. That is the thing. So this is called as cascading rollback because that both are interlinked. This is called as cascading rollback. So the schedule A, how we can write means R1 of X or W1 of X, R2 of X, W2 of X, then C2. Okay, C2 that is committed, then R1 of Y, W1 of Y, then C1 are aborted. C1 means the committed transaction 1 or transaction 1 aborted. Then schedule B same thing, R1 of X, W1 of X, R2 of X, W2 of X, R1 of X, W1 of X. Then C1 means committed transaction 1 or aborted 1. So the not cascadeless, the schedule B below is called as not cascadeless schedule because T2 reads the value of X that was written by T1 before T1 commits. Okay, if T1 fails or aborts, the T2 must also be aborted or rolled back, resulting in cascading rollback. Already we have seen. Okay, that's why R1 of X, W1 of X, then R2 of X. R2 transaction 2 treats the same value what will be written by the transaction 1. W2 of X, R2 of X, W2 of X, R1 of I, W1 of I, then committed C1 or A1. Okay, then strict schedule means cascade schedule is furtherly it will be defined as strict schedule. A schedule in which a transaction T2 can neither read nor write an item X until transaction T1 that has wrote X has committed. Until T1 has committed, the T2 should not perform any read or write operation. That is called as strict schedule. Okay, the set of strict schedule is a subset of cascadeless schedules. Okay, so that's all about the schedules based on schedules are in generally it is divided characterizing schedules by serializability and recoverability. Again, whether the schedules are divided into recoverable schedule and non-recoverable schedule, and also we have seen the what is meant by cascadeless schedule, strict schedule, and so on with example. Whenever we are reading the operations in the corresponding schedule or transaction, so we should read from left to right or none top to bottom. Okay, so that we have to follow. Read operation of a transaction 1 means R read operation. The transaction 1 represent 1 R1. Then what item it is going to read, that is X means X or Y means Y. Same thing for abort means A. Transaction 1 means A1. Commit of transaction 2 means C2 and so on. So these things we should keep it in the mind. Okay, when we are characterizing schedules based on recoverability or serializability.